All right, so this is the in-depth description for the software or MATLAB version of this code. The reason we're using MATLAB instead of Arduino is because Arduino requires you have some sort of hardware to work it, and MATLAB we can do a fully virtual robot. Um, so I'll also have a video of a MATLAB refresher. You'll also need MATLAB for Lab um, 5, the robot kinematics. So might as well get started now if you'd like to. In this version, since we don't have any distance sensors, more emphasis will be placed on the coding on your behalf. So we have a whole set of given MATLAB materials, and that's in this other document. The supplement here goes into everything that's been created for you and how to use it. I'm not going to go into everything here because it's actually quite well explained here, I think. So hit me up if you have any questions with those, but it should be pretty much ready to go. Um, Same thing, you'll have a 5 by 5 maze, but in this case, to show that your algorithm is robust and it handles all the edge cases, we're going to ask you to write your code so that I can do either the right hand rule or the left hand rule. And it's going to be given 10 different test mazes, and you will have a percentage grade based on how many of those tests pass. So first you'll have an explore file that uses the correct rule to traverse a maze. So the rules that we're taking a look at, it's based on the basic algorithm of maze solving. If you're in a corn maze, for instance, as long as you keep one hand on the wall, as long as it's built a certain way, you're always going to get to the end eventually. So we're going to use that principle to either follow the left or the right wall, depending on the test. And then after you explore, you'll have a list of moves that you took, forwards, rights, and lefts, just like we had in the physical labs. And next, you're going to give it to your optimize function. So that's going to get the list, and it's going to delete any dead ends and unnecessary side trips. So we can take a look at that with the GUI code I mentioned in the overall lab video. Um, Here we go. Cool. So take a look at this, see how you would solve something manually, and then check out the string below that's generated and see how you might optimize it. For instance, I'm following the the left hand rule here, because when I was here, I saw a left available and I took it. That's the left hand rule. And when I'm using the left hand rule, a dead end is found by a pattern of 2 rights in a row, which I found here. So this is basically this square here showing that it's a dead end because there was 2 rights there. So you'll have to find the patterns for yourself, but you can use this little string tool to figure out what patterns you might replace. This is just experience because I've done this lab a few times with other semesters, but I can see how to replace things here, and you'll have to do this iteratively. So definitely a while loop will be helpful, because as soon as you solve one dead end, another might show up as you solve it. Cool. In order for the arrows to work again, you'll have to click out. So yeah, something like that, that can show you how to build your algorithm. And that's going to go into the optimize function here. This just gives a little more info about those 10 test cases. You should only have these different situations come across where you're either dead ending to the left, dead ending to the right, or some sort of T-junction where one is a dead end and the other is the correct path. That's the basic types of dead ends. Some of these might be compounded. Like I said, you'll have to do that iteratively. And then this one has a slightly smaller report because there was more coding involved. So that's the overview of what's given in your reports. Here I'll show you what's expected here. So you should have, when you download your stuff from Canvas, all the given functions are draw maze, draw path, get wall, and wrap angle. Lab 4 runs all the tests. Lab 4 GUI is that maze that you control manually with the arrow keys. Tests.mat, that holds all of the test cases that you're going to be graded on. And then here are your explore and optimize. That's going to be written for yourself. So explore is an example of a MATLAB function. So here is a standard header for a MATLAB function. Gives a little quick one-line summary. Here's a more in-depth one and showing the syntax of how you would call it. Here are the inputs. It's the maze structure and the hand rule. More detail is in the supplement document about what those mean. And here's what the function returns, and then your name and date. So this is what's going to be given to you. Some quick hints to start with. You'll want the current position, which comes from the start position of the maze, and then current direction is the starts at the beginning here. You'll have your empty moves list and an iterative variable, and then you'll write your codes to explore. So think about how the logic would work if you're doing it by hand and how you would code that. Get wall will be pretty useful. It's explained in the supplement document as well, but yeah, so that's your explore function. And then here's the optimize function. Same thing, quick summary, long summary, and syntax, inputs, outputs, name, date, and a little bit of starter code. So you'll have just your moves list and which hand rule you followed. And that's what your optimize function will be based on. Here's some helper variables. And then here's how you find if any dead ends still exist. If you give it your list of moves here, from here, and your dead end pattern, which depends on which rule you're following, it's going to give you the indices where this double pattern occurs. And then you know it's not solved if any of those still exist. So you can say while not empty, this variable. Do a step of solving, find the indices again, and keep going. And then as soon as it's done, it breaks out and does its return. So all of this code, except for lab 4 and test.mat, are optional. You don't have to use those. If you want to use them, you can edit them. What we really want to see is that this lab 4 passes all tests. And the way it does that is it extracts the maze structure from tests.mat. And then it'll do the left hand, right hand rules for all 10 mazes. It's going to have the correct results to pull from. And then it's going to run through them all and show you the results at the end. So how many tests passed and which ones failed, if any. So let's see what happened here. Oh, it won't run because this is not a full correct code. So yeah, that's up to you. Here's an example of what it would look like when your code is finished. Here's the first maze, here's my explore path, there's the run path, and it shows it took the most efficient path for left, and then right, and then as it continues, I'm going to go ahead and pause for right now, and then I'll show you what the MATLAB would look like when it's done. Cool. So this is what it printed out once all the tests were done. So it showed me which one it was doing when. So if it throws an error anywhere, you know where it stopped. And then afterwards, it told me that all my tests were correct. And if one of them were wrong, it would show me which one was wrong. And then that should be pretty much it for the MATLAB version of this lab.